Let's do a projectiles question. So here we have a typical kind of question. The particle is projected from a 40-metre cliff top at an angle of alpha above the horizontal at a speed of 25 metres per second. It hits the ground 89 metres from the bottom of the cliff. Find the possible values of alpha and the speed with which it hits the ground. Okay, very first thing to do on pretty much any projectiles and generally speaking mechanics question, draw yourself a sketch. So we're just going to put all of that information into a sketch. So we're going to start off with a 40-metre cliff and then draw its motion. So nice smooth curve, landing 89 metres away. That initial projection had a speed of 25 metres per second, and we always split into vertical and horizontal. So let's split it into vertical, speed of 25 sine alpha, because remember we've got our angle of projection alpha above the horizontal. Our horizontal speed will be 25 cos alpha. Okay, now let's write down what else we know. We know we can treat vertical and horizontal motion completely independently of each other. So let's look at that horizontal motion. We appear to have the most information about that. We know by looking at the horizontal motion that we have an initial speed of 25 cos alpha, a displacement of 89, no acceleration, final speed we don't care about at the moment, and time we don't know that. Okay, so it's basically like a Suvat equation. However, because we have no acceleration, we know the final speed is also 25 cos alpha. Also, because there's no acceleration, we can essentially ignore these. We can just use our formula for speed equals distance over time. So we don't really need to view the horizontal as Suvat. You can if you wish though. We're just going to use speed is equal to distance over time. Okay, so that's from our horizontal motion. Our vertical motion does have acceleration. It's moving under gravity. So for that we are going to need to use Suvat. So our displacement, we know that we've moved down 40 metres. So you must make sure you put it in as negative because you're moving down 40 metres. Initial speed, 25 sine alpha. Final speed, we don't know that yet, but we'll want to know it. Acceleration, minus 9.8. Again, careful that you have minus because you are going down. And t, well, we don't know how long that takes. Okay, we appear to be a little bit short here because we don't really know u because it's got an alpha in it, and we don't know t or v yet. We appear to be one variable short. However, what we can do is we can use these as simultaneous equations. We know that the time is the same in both of these. Also, alpha is the same angle in both of these sets of equations. So if I was to just rearrange this, I can substitute that value of t into here. I've now got only one variable if I'm to use S, U, A and T. My only, well not variable, my only unknown is alpha. Okay, we know it must be the same time that it's moving horizontally as it's moving vertically. Okay, so let's use that information. So I'll use my green pen because I'm using the vertical information here. Minus 40 is equal to 25 sine alpha times t, so ut, and then minus 9.8 over 2 is 4.9 t squared. Okay, so we're just using s equals ut plus half at squared, bearing in mind that we've halved the 9.8 to get 4.9. Okay, a little bit of calculator work to be done here. We can cancel the 25s. We can also find out what 4.9 times 89 squared is. So we're going to end up with 4.9 times 89 squared divided by 25 squared, 62.1. Okay, so this is going to give us minus 40 is equal to 89 tan alpha minus 62.1 sec squared alpha. Again, we don't need to bother writing 1 over cos. We know we can write that as sec squared. Okay, now we see we've got a quadratic, but similar to problems we had in AS maths and that we've done in trigonometry in A2, you need to put it in terms of one trig function. Because my linear one is a tan, I need to change sec squared alpha into tan squared alpha. So we know that sec squared alpha is equal to 1 plus tan squared alpha. If you've forgotten that identity, you can very quickly derive it from cos squared plus sine squared is 1. Divide through by cos gives you 1 plus tan squared is equal to sec squared. You can do that as a very quick little reminder at the corner of your page. Okay, so substituting that into there, we're going to get minus 40 equals 89 tan alpha minus 62.1 plus, minus 62.1 tan squared alpha. We notice it's a quadratic now, tidy it all up, make the squared term positive, and we're going to get 62.1 tan squared alpha minus 89 tan alpha plus 22.1 equals 0. That's too horrible to solve in your head, so calculator. We can see that we get tan alpha is equal to 1.114. I'd go 4 significant figures, just make sure you don't get any rounding error to 3 significant figures later on. And our second solution is 0.3196. Okay, so we've got those. Now we just need to do inverse tan to find alpha. Might just put them down to 4 decimal places instead, so that they're to the same accuracy. Okay. Let's put this in degrees. It's nicer to work in degrees for mechanics. So we've got one angle of 48.1, and our other possible solution is 17.72 degrees. Okay, so we've got the possible angles of projection, and now we just need to find the speed in both cases. So we'll just give ourselves a little bit of space to work with at the bottom here. The horizontal speed doesn't change, so I know my horizontal speed, we'll just do it for this case first of all. You can work for exactly the same thing using the other angle if you need to. Horizontally, I get a speed of 25 cos alpha, but we know that alpha is 48.1. Just put that in the calculator. .6 And then we're also going to find our vertical speed as it hits the ground. Okay, this requires a little bit of SUVAT. I've got all the information I need there though. The only difference is now I know my alpha, I can just plug it in. So looking at my vertical now, I'm going to use v squared is equal to u squared plus 2as. Calculating that, u squared, I'm going to get 346 minus 9.8 times 2 times minus 40, where was I going? Yep. Sorry, plus, and I've got two negatives, that should have been a plus, times 40. There we go. So I know that v squared is 1130.25. Square root of that should give me v. If I put it incorrectly, there we go. Okay, so I've got my vertical speed and my horizontal speed. If I now just do a bit of Pythag on each of these, on both of them, so I get 16.696 squared plus, I might as well use v squared, okay, so you've go answer squared plus 16, whoops, plus 16.696 squared. I get a speed with which it hits the ground of 37.5 meters per second. Okay, just be cautious. When it asks for speed at which it hits the ground, that doesn't have a direction. It's a scalar, not a vector. The velocity with which it hits the ground would be 33.62, 16.696. In fact, it would have been negative of that because it's moving downwards at that time. Okay, that's the velocity. That's the speed. Someone might ask, why did I bother to square root this if I'm just going to square it again? I like to just find out what the square root of it is to check its reasonable number. It started off moving up at about, I forget what that number was now, about 16-ish. So by the time it's come to here, by the symmetry it'll be moving down at about 16, and then it's got another 40 meters to fall. It's going to accelerate a bit more. I got a reasonable number. I like to just do that final check to make sure it's reasonable. Okay, so a quick summary of what we've done. First of all, read the question, translate it straight into a sketch. Once you've got your sketch, you don't need to worry about finding the information there, and it only takes a few seconds. Once you've got that, you know that horizontally, it's simple. You're just using simple speed is equal to distance over time because it's not accelerating. Vertically, you require some SUVAT. So you plug in the information you know, and you know they're using the same value of t. So you can substitute your value of t into here, use the SUVAT equation, tidy it up, you will have a quadratic. This is a common form where you have tan alphas and sec alphas due to the form it rearranges in. Use the identity, set up a quadratic, solve it, and find your angles. Okay, then there might be some follow-up work about speeds or velocities with which it hits the ground. Okay, take your time, split it up, work through the algebra. The algebra is not too bad, it just looks nasty because the numbers aren't nice. You've got your calculator.